Okay, hello everyone. My name is Ajit Mudgarikar and my student ID is 2245866678. I'm here to present my 7.3 HT task for professional practice. I'll go through my project step by step. So I built a coffee shop pipeline. It's a CLI-based coffee shop project, and it is connected to a full Jenkins CI/CD pipeline. It will cover all the stages that are required in the assignment and show how a real application can move from code to production like monitoring. Below is a clear high-level overview. So I've used Go with the Gen framework for routing, Postgres as database, and it has minimal features for now. We can list menu items, create view orders, we can do health and readiness checks, and in the future, in the Jenkins pipeline, Prometheus metrics have been enabled at slash metrics, and I'll go through the deployment later when I cover the pipeline. These are the main endpoints that are available in the application. I've simplified this with a make file. I'll go through the output once. Yeah, so this is how the basic application works. We can test the health endpoint, the ready endpoints to make sure application works. We can first view the menu by calling the endpoint uh, on the V1 slash menu app. We get the whole menu. We can create an order using the same syntax. I've simplified this all with a make file, so it's easier for users to work with the CLI. Uh, when we place order list, we can see my name and the order I just created, and we are able to clear them as well. And if when I clear, the orders list will be empty. This is how the basic app works. Uh, Now I've used Jenkins to uh, configure, test this, and then even push it to production and monitor it. So we start with the build stage. It will compile the Go code in a clean container. Uh, I'll go through it over here. So this is my successful execution. Yeah, we first check out this version control. So I pushed my pushed all my code to Git, so it was able to fetch it from there and pull the latest commit. The build side will then uh, simply build the executable as per using all the Go tools. Then we go to unit tests where we can run tests in isolation that will run quickly. We go through integration tests where here I'm spinning up test containers. We can see in the log here, uh, so that we can see whether the application works fine with Postgres. This is to test the menu endpoint. But for now, it's just testing the menu endpoint, but can be used for other tests as well. So it's a simulated test container using the Ryuk library so that I can perform integration tests. I even provided a benchmark for how long it takes to say hit the menu endpoint. So it was taking around like zero point 0.5 milliseconds per operation, and how many heap allocations per byte. So 320 bytes allocated per operation. We are able to fetch these values as well. I could show the same output on my local. Yeah, so make test integration, make test integration benchmark and the make test. So we can verify whether the app works locally before we push to the pipeline and then eventually to prod. Uh, then we come into the code quality section where using tools like format, Go lint, and GoVet, I was able to make sure the code follows the best by quality practices. So unit tests, integration tests, and then code quality, we make sure the code is readable and follows the organization best practices. In the security stage, I scan for secrets, any vulnerable dependencies, or any risky patterns. This is done again with Golang based tools. Uh, I could show the local output for the same. Yep. So make go will go through all the files and check whether there are any security issues in any files. Uh, Git leaks is mainly used to make sure we are not passing any secret information that should not be passed on public version control systems. They should be kept in secret managers like AWS Secret Manager or something where it stays encrypted. Uh, and Go one check will ensure whether there are any vulnerabilities in the code by going through some OWASP best practices and making sure our code is good enough to go into production. Then we move to the deploy stage. Here I used Azure to create the Docker images and then push them to Azure Container Registry. Uh, Azure Container Registry, I configured a service principal with the ACR push rule. This is considered a best practice. Instead of giving away my raw credentials, I created just this role, which I could show in the pipeline. Yeah, so around here, az-sp-json has all the key credentials. They stay encrypted in Jenkins, and using these, I'm able to push all my Docker images that I create in this stage onto Azure Container Registry. I could show the code for the same. So first, this is the code quality. This is the vulnerability check stage. I run all those three stages, and then this is the deployment stage where I ran the script to first I log into Azure. I start creating the images first, and then eventually once the images are created, they are pushed on this Azure Container Registry URL, and they can be accessed from here if you have the correct permissions. And that was my deployment stage. Code for the same is here as well. Then we move to release. I chose Minikube, which is basically a local cluster for Kubernetes on my machine. Instead of choosing Azure Kubernetes service, which is paid and like will take quite a few takes a lot of money for say configuring a load balancer and stuff. And I didn't want to use any money for this project. So I kept it on my local with Minikube, and it works perfectly fine. It's a safe control rollout with all the Kubernetes best practices, and you can have rollback, auto scaling, everything, as Kubernetes provides the same with its objects that you can configure accordingly. So first, I needed to create a secret that could enable Kubernetes on Jenkins. The kubectl pipeline is the kubectl executable to get all the registry client ID and secret to perform the pull on the Azure Container Registry. Once that is done, I was able to apply all my YAML files. You can view them on my Git repo, and then we do a quick smoke test to ensure everything works. And you can see how it works as expected. And once everything is run, once this stage of the pipeline is complete, I'm able to access my resources using Minikube as well. I could show the output for the same. Yeah, so the Minikube IP on my machine will be as follows, and I'm able to call the menu, get the menu as before from similar to my local development. It also works in production using these scripts. So first the orders list will be empty. Then I use this script to simulate creating a name item and then configuring it to JSON so that it can be passed as a payload. It's a simple script, but if there was a UI, it could have been made more simplified. But for a CLI-based app, this was good enough. And then we get all the orders. So as I pushed it here, I am able to view my order. Once we clear, we won't be able to see it. And so we confirm that the application works fine in production as well. So, yeah, and then finally we come to the monitoring stage where we deploy Prometheus in clusters and a small burst of traffic and query the key metrics. We verify whether the release is healthy and measurable. So the monitoring stage, I simply use Prometheus metrics. We create a basic metrics endpoint. We hit the menu endpoint a bunch of times using a script, and we ensure whether it works perfectly fine. And then I even send an email to it triggers an email to my specified registered email. I could show the same over here. Uh, so this is the local testing of the metrics point, and this is the Minikube testing, where I was able to generate 20 traffic requests to the menu endpoint. How many requests have been generated so far is covered here. Other requests per second were around 0.38, and percentile 90 error, which is 90% of requests are less than 1.81 milliseconds. And configures that concludes the monitoring stage. I'm even able to set up an alert to my email address, and that concludes all the stages that were required to be implemented in this task, and I've done them all. Thank you.